Now that we know about the center of a data set, we next want to discuss the variation and dispersion of that data set. Life would be really boring if everybody was always the same and always at the center, right? So we want to talk about what if everybody's not at the center? What if everybody's kind of all over the place? Namely, spread, right? How spread out is our data set? Now there are four measures we're going to learn, right? We learned three measures of center, the mean, the median, the mode, and now we're going to learn four measures of variation and dispersion. Three of them we're going to learn in this section, namely the range, the variance, and the standard deviation. Those three we're going to learn now. The interquartile range is something we're going to learn in section 3.4, so don't worry about it right now. All right, let's begin with the easiest of these measures, the range. Now, before I even talk about range, let's talk about dispersion, right? So when we see the word disperse, right, spread out, that's what it is a measure of, right? The dispersion of a data set is how spread out that data set is. And it's a number that will give us that. And again, there's four different numbers that will give us that kind of information. The range is the difference between the largest and the smallest values. Now, difference in mathematics means we're going to subtract, and that's exactly what the formula is. The range is the maximum minus the minimum. Now there are some books that'll write that in words, but in our book, in our course, we tend to just view it as a number, right? This number measures the spread. So some books will say, from 2 to 19, whereas our book says 17, because 19 take away 2 is 17. So we're going to tend for the latter, right? And how to find it? Well, I'll show you how to do that when we get there. Although it occurs to me right now that this page number reference is not correct. So I'll just say from section 3.1 and I'll eliminate that for future years. All right, so I have two classes here. I have an algebra class and a stats class. And I took a random sample of students from both, or a random sample of exam scores for both. So let's look at this algebra exam versus this statistics exam. I'm going to give it some color. That way it makes it easier for us to tell the difference. All right, so we are going to find the following. For the algebra class, we're going to find the mean and the range. Well, the mean is 74 and the range is 40. You can trust me. I wouldn't lie to you. That's what the values really are. I promise. I found them. But I'm going to show you how to do it for statistics, so just in case you don't believe me. So if we go to the calculator, and we go to Stat, and we go to Edit, and then we have this old data set that was the PET data from section 3.1, and we want to get rid of it. So I'm going to go up so that the whole list is highlighted, and I press Clear, Enter. That's my favorite way of clearing out data sets. There are a few others, but that's the most efficient. What you never, never, never want to do is go up and press Delete, Enter. That's bad. So you go up, press Clear, Enter, and that will clear out your whole column. And then I want to type in the statistics scores. So I'm going to type those in quickly. And then I want to find the range and the mean. Well, we already know how to find the mean because it's the same thing we learned in section 3.1. Go to Stat, go to Calculate, pick number 1, one variable stat, go down to Calculate and press Enter. And you can see X bar at the top is still 74, so the mean is 74 for that stats exam. Interesting. Now the range is not something that is found with the calculator. However, the calculator finds the min and finds the max, and you could use those to find the range yourself. So that's what we would do. So the mean is 74, and then the range is 100 take away 60, which is 40. So those are the values for the stats exam. Obviously I did the same kind of calculation when I ran it for the algebra exam. I didn't want us to bother doing it for each test. I thought that would get a little tedious, so I just did it for one test with us. All right, now we're going to label the mean and the range on the dot plots below. So you can see the algebra test is up on top. Those 10 dots represent those algebra exams. And the statistics exam is the bottom row of dots. And you can see the stats exam has got a lot more, variability in the numbers, which is what we're going to talk about in a second. So they want us to label the mean and the range. So I'm going to do that. Right here. And there we have it. So the mean is where that red arrow is, right here. So that's the mean right here. And the range is the distance from the lowest to the highest. Now you'll notice it's actually the same value for, oops, I can't do that, for both of these data sets. The mean is in the same spot for both the algebra exams and the stats exams. Similarly, it's also the same lowest value and the same highest value for the min and the max for both the algebra and the stats exam. It's like I planned it that way, perhaps on purpose, huh? Because I want to get at these next questions. If the mean of the two data sets are the same, does that mean the data sets are necessarily similar? Well, no. I mean, look at these two data sets. They had the same mean, but they're very different from each other. I mean, a student in the stats class could be more likely to be failing, more likely to be super high. There's a lot more volatility in the stats course than there are in the algebra scores. So the data sets can have the same center, right? But they're not necessarily very much the same otherwise. All right, so that means that the mean is kind of, I mean, it measures the center, but it doesn't really tell you anything else about the rest of the data. I'm sorry, let me get that out of there. All right, now what about the range? If the ranges of the two data sets are the same, does that mean that they're this similar? And the answer is no, not at all, right? The ranges being the same just means that the min to the max distance is the same, but it doesn't really tell you anything other than that, right? So you can't tell anything about the interior points. What's going on inside of that min and max? All you know is that the distance from min to max is the same. That's it. In other words, we've learned a very important lesson, which is that the range is easy to find, but it kind of is, well, it's not a very good measure of spread. I mean, it's okay, but it has a lot of problems. So that's the moral of the story. The range is easy to calculate, but it's not a very sophisticated measure of spread. It tells the min to max distance, right? But it doesn't give you a good sense of the interior point spread, and honestly, that's more important. What's going on in that inside of that data set with all of those points in between the min and the max? That's way more interesting to us. That means we're going to need to develop another measure or two that will tell us a better sense, actually three, the variance, the standard deviation, and the IQR. Those three numbers are going to give us a better sense of the interior of the data set rather than just the min to max spread. Min-max spread shouldn't be ignored, right? You should still look at it, but it's just not as powerful as those other three measures are going to be. It has a lot of issues. Also keep in mind that the range is not resistant to outliers. If you have an outlier on the high side or an outlier on the low side, the range is just going to get yanked really large to accommodate for those numbers. So it's pretty terrible on a couple fronts. There, I just threw that note in there as well because that's just something to also keep in mind. So it's not resistant to outliers either, which means the range is kind of, well, we need something better.